Hello everyone. In this video, we'll solve LeetCode problem number 34. Okay, this question has been asked in many companies like Amazon, Meta, Google, Infosys, Microsoft. So let's first try to understand the problem. Given an array of integers nums sorted in non-descending order, find the starting and ending position of a given target value. If the target is not found in the array, return -1, -1. You must write an algorithm with O log n runtime complexity. So this question says that you will be given an array of nums in non-descending order. Non-descending means smallest numbers first and then everything in increasing order. You have to find the starting and ending position of a given target. So you will be given a target. You have to find the start and the end position of this given target. So let's take this example 1. In the nums array, you can say 8 has 2 occurrence. 1 is at position 3 and 1 is at position 4. So 3 is our starting position and 4 is our ending position. Now please note, if target is not found in the array, you have to return -1, -1. So let's say if the given target is not present in that array, you have to return -1 for both of them. Or let's say if there's nothing in the array, again you have to just return -1, -1 in an array. You must write an algorithm with 0 log n runtime complexity. Now this is the most important part here. The question says that you need to find the start and the end value of end position of the given targeted value, but you have to find it in the runtime complexity of O log n. Now whatever we'll do here, most of the things would have n square or complexities as such, but you have to solve this in log n. Now to do this, what we are going to do is we'll find the first and the second part of it in using binary search. Now when I say binary search, we'll write two functions, one to find the first position and one to write to find the last position, and then once we find those answers, we'll just return them. So to find the first occurrence or the first position of the given targeted value, what we'll do is we'll write the simple algorithm of binary search, where we'll have left and we'll have right. Left would be the starting point of the array and right would be the end point of the array. And then since we have to return the answer as -1 if nothing is found, I have initialized an answer with the default value of -1. Now we'll have our while loop here. In this while loop, what we'll do is we'll run this while loop until left is either less than or equal to right. Basically, our position, left is the position or the index of an element in an array. So till the left index is less than or equal to right, we'll keep running this loop. Okay, now we need to find a midpoint. Since we are using binary search here, we need to find the midpoint. To find the midpoint, what I've done here is I have taken the left position plus right position, and then I have divided it by 2, and I am getting the floor. So this would give me, let's say for the very first one, my left was 0, 1, 2, 3, 4, 5. So 0 plus 5 would be 5 divided by 2, 2.5. This would give me 2. Okay. Now we have our if else conditions here. In the first condition, I'm checking if nums at mid, if nums at 2 is equal to target. So our number was 2, our index was 2, and at the second index we have 7. So if 7 is equal to the target, which is false, so we'll go to the next if else loop. Okay, if else statement. Here we'll see if nums at mid, if 7 is less than target, we'll do left is equals to mid plus 1. So that and this we are doing because we want to search on the left side. Okay, else we would have done right is equals to mid minus 1. Okay, so every time we have left less than equal to right, we'll try and keep finding this array for the given targeted value. Since till mid we didn't have the targeted number, and this array is in ascending order, which means till here we don't have the target value, till position 2 we don't have the target value. So we have increased the left to mid plus 1, so that our left now is at position 3, and now we can search between 3 and 5. Okay, this decreases our range of search, and whenever we'll find that our midpoint is equal to target, we'll save that midpoint as the index as our answer, and later on, since we have to search on the left side of the array, we'll decrease the right to mid minus 1. Make sure you pay attention to this line. Since we are finding the first value, we are decreasing, we are storing the right as mid minus 1. And why I'm emphasizing on this particular line is because this function find first is similar to this function find last, but the only change that we are doing is in the first find first function, we are making right is equals to mid minus 1 because we want to search on the left side. But in find last, we are making last equal to mid plus 1 because we want to search on the right side. So this would give us the first occurrence position of the given number, and this again would give us the last occurrence of the given targeted number. Let's go through it once again. So left would be 0, which is the starting point of the array. Right would be nums.length minus 1, the end point of the array. Answer would be by default minus 1. If we don't find anything, we'll return the minus 1 as answer. Now we have a while loop running here. So while our left which is the indice, the starting indice, and right which is our end indice, while left is less than equal to right indice, we'll keep running this loop. We'll get our midpoint by using this formula. After getting the midpoint, we'll check if midpoint is equals to the target. If yes, we'll we'll update our answer to the midpoint, and in our left, we'll update our left pointer or left index to mid plus 1 so that our next search happens on the right side. But if our nums at mid is less than the target value, what we'll do is we'll again increase our left to mid plus 1 because the first half of the array does not have the target, so we'll search on the second half of the array. If our nums at mid is greater than the target, then we'll do right equal to mid minus 1 because our first half of the array has the target value. Once we come out of the while loop, whatever is there in the ans, we'll return that. In line number 39, you can see that I have written return first, find first, comma find last. So in find first, whatever we find here, whatever the function finds here would be returned, and in find last, whatever the function finds here gets returned. And that is how we get our target value. Let's try to run this. See, all the test cases are passing. Let's try to submit it. In the runtime it beats 100%, so that's a good sign. So just remember one thing in this question, you need to define two functions instead of just writing one algorithm. You need to define two functions, one to find the first occurrence or the first position of the targeted value, and one to find the last occurrence or the last position of the targeted value. And on that, you also have to make sure that the runtime complexity is O log n. So for both of these we'll use binary search, but just make one tweak, that is whenever we find our mid, nums at mid equal to target, to find the first one we'll change our right. So to find the our first occurrence of the target, we'll update the right as mid minus 1, and on the other hand, to find the last occurrence, whenever we find mid equals to the target, we'll update our left to mid plus 1. This is the key difference that would give you the results. Thank you.